Now we discuss some properties of rings. Let A, B and C belongs to a ring. We know that a ring is a set R together with the two operations addition and multiplication. Then R together with the addition is an abelian group. Also multiplication is associative and multiplication is left and right distributive over addition. Then that set together with the two operations is known as a ring. Here the property is defined as A into 0 is equal to 0 into A is equal to 0. This property holds for a ring also. A into minus B equals minus A into B equals minus of AB. Also minus A into minus B equals AB. Also A into B minus C is equal to AB minus AC. That is multiplication is distributive over addition. Also multiplication is distributive over subtraction. B minus C into A is equal to BA minus CA. That is multiplication is distributive over subtraction. Left distributive over subtraction. Also right distributive over subtraction. That is holds for a ring also. Furthermore, if R has a unity element, a ring may or may not have a unity. If it has a unity, that is unity means multiplicative identity. The unity is not the additive identity. Unity is the multiplicative identity. If R has a unity element 1, that is multiplicative identity 1 exists, then minus 1 into A is equal to minus A. Also minus 1 into minus 1 equals 1. Okay. We have to prove this result using distributive property. Okay. For proving the rules 1 and 2, R is a group with additive identity 0. R is a ring means it is a group, it is an abelian group under addition. So R is a group with additive identity 0. Then definitely 0 plus A into 0 equals A into 0. That can be written as A into 0 plus 0. That is A into 0 plus A into 0. By cancellation, right cancellation, 0 is equal to A into 0. So 0 is equal to A into 0. Also 0 into A is equal to 0. That is the proof of the first one. How can we prove the rule 2? Minus AB plus AB equal to 0. And A minus AB can be written as A into minus B plus AB equals, here in these two terms A is common, taken it outside, A into minus B plus B, that is A into 0, that is equal to 0. So here we prove the second rule also. Now we prove the theorem uniqueness of unity and the inverse. If a ring has a unity, it is unique. But first we prove if a ring has a unity, then it is unique. Also we have to prove a ring, if a ring element has an inverse, that is a ring element is the unit, then that unit is unique. Its inverse is unique. Okay. First prove that if a ring has a unity, it is unique. Let R be a ring with unity. R is a ring with unity, and let this ring has two unities. E1 and E2 are both multiplicative identity. Then for all A element in R, A into identity element equals E1 into A equals A, because E1 is the identity element. Also we choose E2 as the identity element, so A into E2 is equal to E2 into A is equal to A. From 1 and 2, A is equal to AE1, also A is equal to AE2. That means AE1 is same as AE2. So from 1 and 2, AE1 equals AE2. By left cancellation, we cancel out A from the left side. We get E1 equals E2. That is, the two identities are equal. We choose E1 and E2 are two identities, and we get the conclusion as E1 is equal to E2. Therefore, unity of the ring is unique. That means ring has only one unity. Next we prove, if a ring element has an inverse, then it is unique. Let A and B are the multiplicative inverse of X. Here we take A and B are the inverse of an element. That is, that X has two inverses. Okay. A is the inverse of X, therefore A into X is equal to identity. Also B is the inverse of X, therefore X into B is equal to identity. X into B is equal to identity. A is written as A into identity. A into identity is A. And this identity is represented as, XB. E is equal to XB. So A into E is equal to A into XB. Then A into X is equal to identity. So AX into B is written as E into B. Identity into B is B itself. So from this equation we get A is equal to B. This equation we get A is equal to B. That is, A and B are equal. That means the multiplicative inverse of X is only one element. That is, inverses are unique.